Today we're going to talk about equivalent expressions. Equivalent expressions, that's when expressions have the equal number regardless of which value a variable stands for. Some of this is review and some of it is brand new. So the first thing we're going to talk about is combining like terms. Like terms have the same variable. So when I look at C plus C plus C plus C, those are all the same variables, so I am allowed to add those all up for a total of 4C. 1C, 2C, 3C, 4C, and that is the answer. So if I have these V's here, 1, 2, 3, 4, 5, that is equivalent to 5V. In this last example, though, the only thing I can combine are the 3K and the 8K. 3 plus 5K is 8K. I cannot add the 6 to it. 6 does not have a variable with it, and it doesn't have the K attached to it. If it had another variable attached to it, such as an M, I still wouldn't be able to combine it with the 8K. So the only way you can combine variables is if they are exactly the same. That is called combining like terms. Today we're going to apply the distributive property and greatest common factor to create equivalent expressions. You will be given two numbers with either an addition or subtraction sign with them. And the first thing we're going to do is identify the terms. The terms are 40A and 24B. They are the two things that are making up the problem. Second thing I will do is to find the GCF. Now this is something that takes us back to the first unit of the year, and we used Venn diagrams to find the greatest common factor. And so I'm going to refresh your memory on how to do that. You're going to prime factor 40 and 24. Find two numbers that multiply 40 to get 40, and that 4 and 10 work. There are lots of options out there. 2 times 2. Then we start circling our prime numbers. The list of prime numbers, if you remember, is 2, 3, 5, 7, 11, 13. Those are the most common prime numbers. 10 can also still be broken down into 2 times 5. 2 is prime, circle it. 5 is prime, circle it. 24, I'm going to split into 12 times 2. 2 is prime, circle it. 12 can be broken down into 4 times 3. 3 is prime, circle it. 4 can be broken down into 2 times 2, and those are both prime. Now to place them in our Venn diagram, it's matching. For every match, 1 goes in the middle. I have a 2 on the left, a 2 on the right, 1 goes in the middle. A 2 on the left, a 2 on the right, 1 goes in the middle. A 2 on the left, a 2 on the right, 1 goes in the middle. No match for 5, that stays on the outside, and no match for 3, that stays on the outer side on that side. The greatest common factor, again, can be multiplying all the numbers in the middle. 2 times 2 is 4, times 2 is 8. The greatest common factor of this example is 8. Now I will rewrite the expression with factoring out the greatest common factor. Actually, your picture tells you the entire answer. In the middle, we write our GCF. Then, in parentheses, we put the answer in the outer left ring. If there's more than one number, we would multiply those, but there's a 5. We put our addition sign with them, and then on the other side, we have a 3. Now, one last piece, we have to look for variables. Attached to the 40 was an A, so attached to the 5, we need an A, and attached to the 3, we will need a B. Not all of your examples will have variables, but you do need to look for them and include them in your final answer. Let's try a couple more together. 28 and 7. 28, 7 times 4. 7 is prime. 4 can be broken down into 2 times 2. 7 is prime. We can circle it right from the beginning. Now we place our numbers into our Venn diagram. 7 matches with 7, goes in the middle. The other 2's do not match with anything. And we're done. Now we need to write our answer. Remember, it's greatest common factor, parentheses, and this has an addition sign in the center. So the greatest common factor is 7. On the outer left circle over here, 2 times 2 is 4. And in the right, there's nothing. And if you remember from when we learned this in the first unit of the year, empty circles in a Venn diagram represent the number 1, not a 0, so be careful of that. And there is one variable, and it's attached to the right-hand side, so that is where we will leave our number, our variable. And one last example, 40 and 25. Let's start with 25. 5 times 5, both prime, circle them. 40, 10 times 4. 10 can be broken down into 2 times 5. 2 is prime, 5 is prime, and 4 can be broken down into 2 and 2. Venn diagram. 2 doesn't match with anything, outer ring. 5 matches with 5, inside. 2 doesn't match with anything, outer ring. 2 doesn't match with anything, outer ring. And don't forget to go over and check out that last 5. That does not have a match, and that belongs in the other outer ring. Okay, so again, we have our GCF, parentheses, plus parentheses. So greatest common factor comes right from the middle, that's 5. Left outer ring, 2 times 2 times 2 is 8. Be careful not to say that it's 6. There's a variable D attached with that. And the other outer ring has a 5 and a Y attached to that. And that is how we take an expression and create an equivalent expression through the greatest common factor and the distributive property.